Hello, my dear students. Today we are going to continue our discussion on Chapter 1, which is the main transition elements. We are going to discuss the physical and chemical properties of iron, and we are going to discuss the types of iron oxides. So let us start. My dear students, we are going to discuss the properties of iron. First, we are going to discuss the physical properties of iron. The physical properties of iron depend on the purity and the nature of its impurities. And its alloys and steel have different properties and uses. The iron melts at 1538 degrees Celsius and has density 7.86 gram per cubic centimeter. We have give reason in this point. Pure iron has no industrial use. The reason for that, because it's relatively soft and not hard, which is malleable and ductile and ferromagnetic, strongly attracted to a magnet. Now we are going to discuss the chemical properties of iron. The chemical properties of iron, the iron doesn't show the maximum oxidation state corresponding to removal of all its valence electrons from 3d and 4s. The two oxidation states that are used, positive 2 oxidation state corresponding to losing 4s electrons only, and positive 3 oxidation state corresponding to stable configuration, which is 4s0 and 3d5. Now we are going to discuss the chemical reactions of iron. The effect of dry air. The red hot iron reacts with dry air or oxygen, giving magnetic iron oxide. As shown on the screen, iron, when oxidized by oxygen of air, it gives magnetic iron oxide, which is black, as shown on the screen. The effect of water. The red hot iron above 500 degrees Celsius reacts with water vapor, giving magnetic iron oxide that has black color, and the hydrogen gas is released. As the equation proceeds on the screen, 3Fe plus 4H2O at 500 degrees Celsius, it gives Fe3O4 magnetic iron oxide and releasing 4 molecules of hydrogen. The reaction of iron with non-metals. Iron reacts with chlorine to form iron 3 chloride, or we call it ferric chloride. As shown on the screen, the equation proceeds. Iron plus chlorine by heating gives iron 3 chloride, which has red-brown color, as the following animation shows. As shown on the screen, here iron is heated in the presence of chlorine gas. Here we form iron 3 chloride that shown on the screen that has brown color. Now we are going to discuss the reaction of iron with sulfur. It forms iron 2 sulfide or ferrous sulfide. As the equation shown on the screen, iron plus sulfur by heating gives iron 2 sulfide or ferrous sulfide that has gray color. Now we have give reason in this point. Iron reacts with chlorine, giving iron 3 chloride, not iron 2 chloride, while it reacts with sulfur, forming iron 2 sulfide. The reason for that, because chlorine is a stronger oxidizing agent than sulfur, such the chlorine has higher electron affinity. Now we are going to discuss the reaction of iron with acids. Iron reacts with dilute mineral acids to form iron 2 salts and hydrogen. As the equation proceeds on the screen, iron plus dilute hydrochloric acid or concentrated, it gives iron 2 chloride or ferrous chloride, and the hydrogen gas is released, as the following animation show. Here, the iron is put in beaker containing dilute hydrochloric acid. As shown on the screen, hydrogen bubbles are formed as replacing iron the hydrogen of the hydrochloric acid. And also, my dear students, iron reacts with dilute sulfuric acid, giving iron 2 sulfate or ferrous sulfate that has green color and releasing hydrogen gas. Now, my dear students, we have good reason in this point. Iron reacts with dilute hydrochloric acid or sulfuric acid, forming iron 2 salt, not iron 3 salt. The reason for that, because the produced hydrogen gas is a reducing agent that prevents the formation of iron 3 salts. Now, my dear students, we are going to continue our discussion on the reaction of iron with acids. But here we are going to discuss the reaction of iron with concentrated acids. Iron reacts with concentrated sulfuric acid, giving iron 2 salt and iron 3 salt and sulfur dioxide gas and water. As the equation proceeds on the screen, iron reacts with sulfuric acid that concentrated and heating, giving iron 2 sulfate and iron 3 sulfate and sulfur dioxide gas and water vapor. Here, my dear student, the reaction here different from dilute sulfuric acid, as a concentrated sulfuric acid is a strong oxidizing agent. So, as it forms iron 2 sulfate, it oxidizes it into iron 3 sulfate, and the sulfuric acid is reduced into sulfur dioxide and water. So, we have good reason in this point. Iron reacts with conc sulfuric acid, forming iron 2 salt and iron 3 salt. The reason for that is sulfuric acid is a strong oxidizing agent, giving both iron 2 and iron 3 sulfate as the equation proceeds on the screen. Another good reason in this point, my dear students. Iron does not react with concentrated nitric acid. Here the reason for that is due to the passivity of iron, in which a protective non-porous layer of the iron oxide is formed on its surface, which has larger size molecules than the metal molecules that prevent the metal from further reaction. My dear student, notice that the metal oxide layer is removed by using dilute hydrochloric acid. Also, notice that iron 2 salts are reducing agent, while iron 3 salts are oxidizing agents. Now, we are going to discuss the iron oxides. We are going to discuss first iron 2 oxide or ferrous oxide. The preparation of iron 2 oxide. From iron 2 oxalate, as the equation proceeds on the screen, iron 2 oxalate, by heating in the absence of air, it decomposes into iron 2 oxide and carbon monoxide and carbon dioxide. And my dear student, we have good reason for this equation. Heating iron 2 oxalate in the absence of air does not give iron 3 oxide. The reason for that is the carbon monoxide is reducing agent, so prevent formation of iron 3 oxide. Here, the second way for preparation of iron 2 oxide is the reduction using hydrogen or carbon monoxide gas. As the equation proceeds on the screen, iron 3 oxide is reduced by hydrogen in the range 400 till 700 degrees Celsius, giving iron 2 oxide and water vapor. Or using magnetic iron oxide, we have to reduce it by hydrogen in the range also 400 till 700 degrees Celsius, giving iron 2 oxide and releasing water vapor. What are the properties of iron 2 oxide? It is black, solid, insoluble in water, reacts with dilute acids. As the equation proceeds, iron 2 oxide with dilute sulfuric acid giving iron 2 sulfate and water is produced. Here the oxidation and reduction. So when oxidation of iron 2 oxide by oxygen of air, it gives iron 3 oxide, while its reduction by hydrogen or carbon monoxide above 700 degrees Celsius, it gives iron releasing water vapor. Now we are going to discuss iron 3 oxide or ferric oxide that has chemical formula Fe2O3. The preparation of iron 3 oxide by heating iron 2 sulfate or iron 3 hydroxide. As the equation proceeds on the screen, heating iron 2 sulfate, it gives iron 3 oxide and sulfur dioxide gas and sulfur trioxide gas. My dear students, we have give reason in this equation. Heating iron 2 sulfate gives iron 3 oxide and does not give iron 2 oxide. The reason for that is the produced sulfur trioxide gas is oxidizing agent, so prevent the formation of iron 2 oxide. It oxidized into iron 3 oxide. The second step for getting iron 3 oxide, or the second way, the heating iron 3 hydroxide above 200 degrees Celsius that produce iron 3 oxide and releasing water vapor. My dear student, notice that when reaction of iron 3 chloride and ammonium hydroxide, it gives iron 3 hydroxide and ammonium chloride is formed. My dear student, we use this last equation on conversion of iron 3 salts into oxides. We have to react it first with ammonium hydroxide to give the iron 3 hydroxide that can be by heating gives iron 3 oxide, and we can make the conversion for the solving these equations. Now we are going to discuss the properties of iron 3 oxide. It occurs as hematite and it is insoluble in water. It is used in red pigments and in paints and rouge. It reacts with conc hot acids. As the equation proceeds on the screen, iron 3 oxide plus sulfuric acid that concentrated and by heating, it gives iron 3 sulfate and water. My dear students, remember that iron 2 oxide plus sulfuric acid, the condition of sulfuric acid is dilute, while iron 3 oxide on reaction with sulfuric acid, it is concentrated and heated to give the salt and water. Now we are going to discuss the third type of oxides, which is magnetic iron oxide that has chemical formula Fe3O4. The preparation of it by passing steam or hot air over red hot iron. As the equation proceeds on the screen, here iron that oxidized into magnetic iron oxide, or the reaction of iron with steam at 500 degrees Celsius, it gives magnetic iron oxide releasing hydrogen gas. Here the reduction of iron 3 oxide into magnetic iron oxide. As the equation proceeds on the screen, iron 3 oxide plus carbon monoxide at temperature ranges from 230 till 300 degrees Celsius, it gives magnetic iron oxide and releasing carbon dioxide gas. The properties of magnetic iron oxide. It has magnetic property. It reacts with concentrated hot acids to give iron 2 and iron 3 salts. As the equation proceeds on the screen, magnetic iron oxide reacts with sulfuric acid concentrated and heat. It gives iron 3 sulfate and iron 2 sulfate and water is produced. My dear student, this equation proves that magnetic iron oxide is mixed oxide, as it gives iron 2 salt and iron 3 salt. That means that magnetic iron oxide is mixed of iron 2 oxide and iron 3 oxide. Here is the oxidation of magnetic iron oxide in air. As the equation proceeds on the screen, magnetic iron oxide plus oxygen, it gives iron 3 oxide. Now we are going to discuss some questions on this part. Here, write the names and symbols of the compounds indicated by letters from A to K in the following diagram. As shown on the screen, we have to know the compound A. As shown on the screen, iron, when reacts with oxygen or water vapor, it must give magnetic iron oxide. So, looking at compound B, that is produced by heating iron 2 carbonate and heating iron 2 oxalate. So, it must be iron 2 oxide. If you look at compound C, that is produced from oxidation of iron 2 oxide, yes, the answer it will be iron 3 oxide. That also produced from heating iron 3 hydroxide or heating iron 2 sulfate. Now looking at compound D. When reaction of iron 3 oxide with sulfuric acid, it must give iron 3 salt. It will be iron 3 sulfate. That on reaction with ammonium hydroxide, double substitution reaction takes place, giving iron 3 hydroxide, which is reddish brown percepted. Now looking at compound F. Here, when iron 2 oxide reacts with dilute sulfuric acid, it reacts by double substitution reaction also and giving iron 2 sulfate. That reacts with sodium hydroxide by double substitution reaction. It gives iron 2 hydroxide, which is white-green percepted. Now looking at letter H. Here, when iron reacts with sulfuric acid, that is dilute, it must give iron 2 sulfate. Here, iron 2 sulfate, when reacts with sodium hydroxide by double substitution reaction, it gives iron 2 hydroxide, which is white-green percepted. Now looking at compound J. When iron reacts with chlorine, it forms iron 3 chloride. This iron 3 chloride, when reacts with ammonium hydroxide, gives compound K. This reaction by double substitution reaction, so it produces iron 3 hydroxide, which is reddish brown percepted, and ammonium chloride. Now, next type of questions is choose the correct answer. When magnetic iron oxide reacts with concentrated sulfuric acid, what is produced? Is it iron 2 sulfate and water, iron 3 sulfate and water, iron 2 sulfate and iron 3 sulfate and hydrogen, or iron 2 sulfate and iron 3 sulfate and water? If you think about it, yes, the answer it will be iron 2 sulfate and iron 3 sulfate and water. Remember, my dear student, is magnetic iron oxide is mixed oxide. Next point, we can get iron 3 chloride by what? Reacting dilute hydrochloric acid with iron, passing chlorine gas over red hot iron, passing hydrogen gas in iron 3 chloride solution, or passing hydrogen sulfide in iron 2 chloride solution. If you think about it, yes, the answer it will be passing chlorine gas over red hot iron. On passing hot steam over red hot iron, it gives what and hydrogen? Is it iron 3 hydroxide, iron 3 oxide or iron 2 oxide or magnetic iron oxide? If you think about it, yes, the answer it will be magnetic iron oxide. Next point, on heating iron to oxalate in absence of air, what is produced? Is it magnetic iron oxide or iron 3 oxide or iron 2 oxide? If you think about it, my dear students, the answer it will be iron 2 oxide. When iron reacts with dilute sulfuric acid, iron 2 sulfate is formed, not iron 3 sulfate, as what? Iron 2 ion is more stable, the evolved hydrogen gas is a reducing agent, the dilute sulfuric acid is an oxidizing agent, or iron 3 ion is not stable. If you think about it, yes, the answer it will be the evolved hydrogen gas is reducing agent. Next point, on heating iron 3 oxide by carbon monoxide gas at temperature 230 degrees Celsius till 300 degrees Celsius, it is reduced to what? Iron 2 oxide or iron or magnetic iron oxide or iron 2 carbonate. Yes, if you think about it, my dear student, the answer it will be magnetic iron oxide. Now, next type of question, give reason for. Iron reacts with chlorine, giving iron 3 chloride, not iron 2 chloride, while it reacts with sulfur, forming iron 2 sulfide. The reason for that, because chlorine gas is a stronger oxidizing agent than sulfur, as it has higher electron affinity. Next point, iron reacts with dilute acids, forming iron 2 salts, not iron 3 salts. The reason for that, because the produced hydrogen gas is a reducing agent that prevents formation of iron 3 salts. Next point, iron reacts with concentrated sulfuric acid, forms both iron 2 salts and iron 3 salts. The reason for that, because sulfuric acid is a strong oxidizing agent, giving both iron 2 and iron 3 sulfate. As the equation proceeds on the screen, iron plus sulfuric acid concentrated in the heat gives iron 2 sulfate and iron 3 sulfate, and sulfur dioxide gas and water is produced. Next point, iron does not react with concentrated nitric acid because iron forms non-porous layer of iron oxide on its surface, preventing further reaction with the acid, as it is non-porous layer, such their molecules larger than the metal molecules. Next type of question, what is meant by alloys? Two or more metals can be mixed together to form alloy, which also may be formed by metal and other non-metal such as carbon. Interstitial alloy. The interstitial alloy formed when new atoms are introduced in the spaces between the metal atoms in the crystal lattice shape, due to their small size causing a change the physical properties of the metal, malleability, ductility, melting point, and electric conductivity, and magnetic property and the strength of the alloy to be harder than pure metal. And for example, iron carbon alloy that we call steel. The substitutional alloy, it is formed when the introduced atom replaces some of the metal atoms in the crystal lattice shape, and this occurs when the introduced atoms have nearly same diameter, same chemical property, and same crystal lattice structure. For example, gold copper alloy, iron nickel alloy, and ferrochrome alloy in stainless steel. The intermetallic alloy. They are formed when the elements forming the alloy combine with each other to form a chemical compound with new properties. And the formula of the formed compound disobeys the law of valence, and the formed compounds are solids and they cannot be formed by the metals of the same group. For example, nickel aluminum alloy and the copper aluminum alloy that called duralumin, and lead gold alloy that has chemical formula Au2pp, and cementite alloy Fe3C.
My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So till we meet again, my best wishes for you.